Hello everyone. Today we will introduce a very useful knowledge point in the process of software development, fault location. Here's a paper that explains it for us. The title is Software Fault Localization via Probabilistic Modeling by Colin Johnson. Let's start it. First one is concept. The paper introduces a novel concept for software fault localization using a probabilistic model. It moves away from traditional methods that rely on the differences in execution paths to identify faults. Instead, it measures the utility of information that a program generates while executing to approximate its progress toward solving the assigned task. The second is implementation. To realize this concept, the paper proposes a Navier-Bayes model recalculated at each line of code during program execution. This model's accuracy in predicting the program's output based on the accumulated information indicates the program's progress. Faults cause a dip in this accuracy, serving as indicators of potential errors. The third is core-related work. The paper builds on various fault localization techniques from the literature. It discusses human-driven methods and automated approaches like program slicing and spectral testing, and it expands on these by integrating AL and machine learning methodologies, particularly focusing on areas where other methods struggle, such as non-branching code blocks. The fourth is input data characteristics. The input data consists of program code and a set of test cases in the form of input-output pairs. The paper uses these to Python programs for illustration. The fifth is type of evaluation. The evaluation includes two experiments using the two aforementioned Python programs. The first experiment tests whether the program progress measure reflects actual progress, and the second assesses whether the measure can detect faults. These experiments use a significant number of random test cases to validate the proposed method. The next is representative image figures within the paper, such as Figure 2, visualize the program progress measure and demonstrate how it varies between correct and faulty program executions. In conclusion, the paper provides a fresh perspective on software fault localization by leveraging a probabilistic model that quantifies the informative value of code execution, marking a departure from traditional path-based fault localization methods. The following is the address of the paper. Welcome to read. That's all for today's explanation. Thank you for watching.